Dr. Dave Semelink from GoDigitalSA Foundation. Today we're doing Unit 12, Independent Final Project. And note that this is the last unit in the series. So, we'll start by looking back. We'll have a review of the computer science concepts we have covered, and then we'll have a chance to brainstorm. The project overview: you will use the design thinking approach to create an original project that serves a purpose by solving a problem and filling a need. You will need to show what you know, learn and demonstrate something new, include a maker component, and demonstrate the use of the following concepts: coordinates, booleans, bits, bytes, and binary, radio communications, and arrays. Okay, so we're going to go over these concepts: coordinates, booleans, bits, bytes, and binary, radio communications, and arrays. Now, name one thing you've learned from each of these lessons. So coordinates: the 5x5 grid of LEDs on the microbit represents a coordinate grid with a horizontal x-axis and a vertical y-axis. The origin, 0, 0, is in the top left corner, over here. The values of the y-coordinates range from 0 to 4 and increase from top to bottom. So here y is 0, y is 1, y is 2, y is 3, y is 4. Individual LEDs can be turned on and off through the LED plot and unplot blocks. The current value of an LED can be checked and its brightness can be changed as well. Booleans. A boolean is a data type that only has two possible values, true or false. You can use boolean variables to keep track of the state of a game. Game over is either true or false, or check to see whether a certain action has taken place yet. Message sent is either true or false. Boolean operators such as and, or, and not allow you to combine boolean expressions to make more complex conditions. Bits, bytes, and binary. Computers work with the base 2 number system. Each place value is twice the previous one. Binary numbers only have two possible values, 0 or 1. A bit is the smallest unit of information. A bit can be either 0 or 1. A byte is a sequence of 8 bits. A bit can be used to hold a Boolean value where 0 is false and 1 is true. Radio communications. Radios use electromagnetic waves to send messages through the air. A radio communication system requires a transmitter to send messages and a receiver to receive messages. On the back of the microbit, if you look closely in the upper left corner, there's an antenna, which is how the microbit can send and receive messages through radio waves. You can send a number, a string, or a string number combination in a message. You can give a microbit instructions on what to do when it receives a radio message. Okay, so remember, the Bluetooth antenna is up here. Arrays. An array is a list or a collection of similar things. Arrays in make code are used to store and retrieve numbers, strings, musical notes, or sprites. Every spot in an array can be identified by its index. The first spot in an array is always index 0. Objects can be accessed, changed, added to, or removed from an array using their index. 3 common methods of sorting elements in an array are bubble sort, selection sort, and insertion sort. Okay, final project brainstorm. You'll be creating a final project with the microbit that incorporates all the concepts we have covered so far in class. Get in groups of 4 to brainstorm ideas for your mini projects. Think about all the concepts we've covered so far and the projects you've created. Your final project can build off an existing project or be something brand new. So what we learned: we had a fresh look at the computer science concepts we have covered, and we had a chance to brainstorm for your final project. Okay, so the next time we'll code and make a final project. Okay, so lesson B, coding and making a final project. What we'll learn: we'll design a unique project and build it. So the final project, design a project by yourself that serves a purpose by solving a problem and filling a need. And then you need to show what you know and learn and demonstrate something new and include a maker component. Okay, and remember, maker component, that means you're going to make something using cardboard or wood or something else that the microbit is going to be mounted on. Project expectations. Use a design thinking approach and ensure the project meets these specifications. You're going to create an original project using the microbit, incorporate a physical component to the project, and demonstrate the use of the following concepts: coordinates, booleans, bits, bytes, and binary, radio communications, and arrays. So some project ideas: create a game, create something that helps somebody by solving a problem, create something beautiful, or create a musical instrument. Okay, baseball pitch counter. This project straps to a pitcher's arm and uses the microbit accelerometer to record how many pitches have been thrown in a session. So you see, we take the microbit and we strap it to the pitcher's arm, and every time he pitches, it has to count one. Okay, so let's see how that's going to work. Open our browser. I've got the pitch counter code here. Okay, and let's say we also want to send the count value to another microbit, so it will be displayed on that microbit. So we're going to use the radio. So on start, we set the radio group. In this case, it's been set to 36. That means that we have to also set it to 36 on the receiving microbit. And we're setting the transmitter power to 7. So that's just to make sure that it's powerful enough to reach the other microbit. And we've created a variable called count, and we're setting this to 0. Okay, so inside our forever loop, we're going to say if the acceleration is greater than some value. Okay, and here we can experiment. So I've just started with 100. So if the acceleration is greater than 100, then we want to see what the acceleration is, and we can show a graph showing how strong it is. So that if the acceleration is less than 150, then we do a little bar graph with 2 steps. If the acceleration is less than 200, which means it's greater than 150 but less than 200, then we show 3. If it's less than 250, then we show 4. And otherwise, if it's not less than 250, then we show 5. Okay, and after each one of these, we pause for 2 seconds. Okay, we're sure that the pitcher isn't going to pitch more than 2 times every 2 seconds. So we pause for 2 seconds so that we can see it. Okay, so now remember that at the beginning, we check to see if the acceleration is greater than 100. So each time the acceleration is greater than 100, it's going to change the count by 1. Okay, then after it's done that, then it clears the screen and it sends that value, the count value, via radio. Okay, so if we look here, we accelerate. Okay, that's 495, so you get all 5 bars. It's 391, so you get 2 bars, and we get 5 bars. Remembering that it pauses for 2 seconds after each one. Okay, and each time it sends it to the radio receiver. Okay, so on the radio receiver, we want to show that value. So whenever we receive a number, we have to display it. We'll say show number. We're going to show that received number. So every time that acceleration on the first microbit is greater than 100, it's going to increase the count by 1, and then it's going to send the count value. So on the receiving microbit, whenever it receives that number, then it displays the number. Okay, so this is a simple way to do it. You can do it in much more sophisticated ways. Okay, so that's the pitch counter. Okay, another example, it's a wrist-mounted step counter and compass. So this project straps to your wrist, displays a compass that updates as you walk around, and it keeps track of your steps. The microbit is elevated to allow room for the battery pack to fit underneath. Okay, so we'll have the microbit. We want it to show the direction we're going in. It'll have a strap to strap to our arm. And it's been mounted like this so that the battery can fit underneath. So you strap the two to your arm. Okay, so let's go back to the browser and start coding. Okay, so I've created this code, step counter. So here, in this case, we're going to say on shake, it's going to change a variable step counter by 1. So we've created a variable that we called step count. Every time we shake it, it's going to change it by 1. If you press button A, then we want it to show the number of steps. So it's going to take the step count, add it to steps, and it will show that string. And we can use buttons A and B pressed together to reset the step count to 0. Okay, so that's the counting. And then we want to show the direction. We'll do this on button B pressed. And we'll use compass heading. We'll say that if the compass heading is less than 22 degrees, or it's greater than 337 degrees, then we show the string N for north. If it's less than 77, then we show northeast. If it's less than 112, then we show east. If it's less than 157, we show southeast. Less than 202, we show south. Less than 247, we show southwest. Less than 292, we show west. And otherwise, we show northwest. Okay, so this is a project where we can see what direction we're heading in, and it will count our steps. Okay, next project, a violin tuner. This project uses a piece of cardboard to mount the microbit to the side of a violin. The student wanted to use it to tune his violin by playing a specific series of tones. The microbit displays the note being played. Before we can make a violin tuner, we need to learn something about violins and how to tune them. So I've looked up how to tune a violin, and here it shows tuning using a piano. So the violin's got 4 strings. The first string is this G on a piano. The next string is this D. The next string is A, and the top string is E. So on the make code, we want to play these notes when you press button A. So how can we do that? Okay, so we know we need music and we know we need button A. So I'll take button A. And I'll play a tone. So the first tone is going to be a low G. Then the next tone, let's go back to how to tune. The next tone is the D above the middle C. The next tone is A. And the last one is E. Okay, so we probably want to play it for a fairly long time, so let's make it 4 beats each. And we'll put a pause in between each one. And pause for 1 second. This is one way to do it. And you can think of other ways of doing this. Here we've got an example, a trumpet angle detector. This example was used for marching band practice, where students must hold the trumpet at a 15-degree angle to avoid hitting the person in front of them or playing directly into their ears. Because the trumpet is heavy, new trumpet players tend to let the trumpet droop. This displays an icon, a check mark, or an X to help new trumpet players learn what the proper angle is supposed to feel like. Okay, so let's take a look at that. Okay, so here we'll create a new project. We'll call this trumpet angle. Okay, here, so we want to check to see the angle all the time. So we'll use a forever loop. And we want to check to see that the angle is always 15 degrees. So we'll use logic. And we'll say if the angle is, let's say, less than a few degrees less than 15, so let's say less than 13 degrees, or greater than 17 degrees. So we can say we're going to have an OR, and we'll compare if the angle is less than, let's say, 13 degrees, or greater than 17 degrees. Okay, how do we get the angle? That's an input. We've got a rotation. Take rotation again. Okay, so if it's less than 13 or greater than 17, then we need to do something. Let's just display something for now. We need to show that this is wrong. We'll display a big X. Okay, let's see how that works. Okay, so now I need to show that otherwise we can just clear it. Okay, we'll probably need to pause. So we'll show the X for a short time and then clear the screen. Okay, I need to debug this because we're not getting it within the 15 degrees. Okay, we can display a variable by debugging. So let's start by creating a variable. Call this angle. Okay, and every time around the loop, we will set the angle to the rotation. And this means that I can actually use angle here. Okay, so every time around the loop, I set the angle to the rotation. And then if the angle is less than 13 or greater than 17, it shows an X, otherwise it has to show a check. Okay, now we can debug. We can see angle is 0. Angle is -2. Angle was 2. Okay, so in the simulator, it's very difficult to get an angle more than just a few degrees. So we can try this with other angles just to see that the code works. So let's say that if it's smaller than, it will stop debugging. Let's try it at smaller than -1 or greater than +1. So we want it to be around 0. So we can see in this case, it's normally a check because it's normally sitting at 0. If I tilt it the one way, we get an X. If I tilt it the other way, we get an X. If it's 0, then we get a check. Okay, so that shows that the code works. We can check an angle between any two values. On a real microbit, we can check it between, let's say, 15 -2 degrees and 15 +2 degrees. So 13 degrees to 17 degrees. Okay, so that's our angle detector. And if we like, let's say that the trumpet player has got an earphone. We can then play a tone. If it's wrong, okay, so he can keep an earphone in his ear, and whenever he's got the trumpet at the wrong angle, it will play a tone. So he knows he has to correct it. Okay. So that was our trumpet angle. Okay, so what we learned today, designed a project and built it. Okay, so we end with the final project showcase. And here we're going to have to end the series. We normally do these sessions in a school, in a computer lab, or in a makerspace. And so you need to work, usually you need to work with other people. You work together to create your projects. So because we're doing this over the air, and because it's the end of the school year, what we will do is we'll leave it for now. And then when school's over, we would like you to get in touch with us and see if you can join us in a project session at a school in your area. Okay, so final project showcase, the amazing inventions everybody made. Okay, so you need to give a demo of how your project works, show how the code works, show how you assembled the the physical or maker component. Tell us how you used one concept you knew, and tell us how you learned something new. Okay, so how did you start the process of designing the product, meeting your goals? What did you hope to learn? What challenges did you face? How did you overcome them? What was the outcome? What did you learn in the end? Who in the class or the group provided help to you along the way, and how did they help you? What were you proud of? What would you do differently next time? Okay, and if you like, you can pause the video to read the text. So what we learned? Okay, we learned a lot, and that we're all very creative. Okay, that's the end of this series. We hope to hear what projects you've made, or we hope to see you and help you to make some projects at your school. So thanks, and stay tuned for a new series coming soon. I'm Dave Semmelink from GoDigitalSA Foundation, and I hope to hear from you. Bye.